Hi, and welcome to Prototype. We will be solving the problem for LeetCode 1480, running sum of 1D array. This is the first problem in the LeetCode 75 study plan. All right, let's read the description. Given an array nums, we define a running sum of an array as running sum of I equal to the sum of nums from the 0th position, so the first number, to nums of I, the ith position. Return the running sum of nums. Let's look at the example. We're given an array of size 4 with the elements 1, 2, 3, and 4, and then we're expected to produce the array of also size 4 with the elements 1, 3, 6, and 10. Well, if we look at the first number of nums, we're given 1, and then our output should just be 1. For the second number, we're given 2, and then we're expected to get an output of 3. And then let's look at the third one. We're given the number 3, and then we're expected to get the number 6. So how is this happening? Well, it's 1 plus 2 is 3, and then 1 plus 2 plus 3 is 6. So we're taking the current number at the ith position, let's say 3, and then we're adding the previous values, summing the previous values plus the current number to get the ith position of the output array. All right, let's start by, what are we trying to return? An array. So let's do that. So let's say const result is equal to an array, and then we'll need one more variable for the sum. So let's say let's sum, and then what do we initialize it to? 0 probably makes the most sense. Now for let I equals 0, I less than nums dot length, and then I plus plus, so iterating through every element of the array. What are we trying to do? Calculate the sum. How do we do that? Well, sum is equal to the current sum plus the nums of I, the ith position in the input array. And then what are we trying to do with the sum? Well, we want to add it to our answer. So result.push sum, and then we can just return our result. We run it, and surely enough, it passes the 3 test cases given. Do quick analysis. So we have a nums array. It has a length of n, so the number of elements in the array. We're going to iterate through every single element. Okay, so time complexity is linear, so big O of n. And in terms of space complexity for our solution, well, we're creating a new array. This will have the exact same size as the input array nums. So we're using linear space. Well, we can actually do a little bit better by using the nums array. So we effectively change the elements in nums in place. So let's do that. Let's return nums. We'll get rid of our variables. And now again, what was the relation? The current num of I is equal to the current nums of I plus the previous. Well, we can just do some assignment. So the previous nums of I minus 1. Now let's look at the example one more time. So let's say we're at position 2. Okay. What did we say? We said that it would be positioned to. Okay, let's look at position 2 of the nums array. It is 2. Now, what did I say to get to the compute the element of our output array? It's going to be 2, the current number, plus the sum of the previous number, so 2 plus 1. Okay, so now it's 3. Next number, we're going to get 3. Okay, so currently our array looks like 1, 3, 3, 4. Okay, now what is our current number? It is 3. And we're going to add and assign it to the previous value, which is currently 3. Okay, so 3 plus 3 is 6. And then we're going to do that one more time. It will be 4 plus 6 to get 10. All right. Now let's run this, and you'll see that it actually fails. Why does it fail? Because we're starting at the first element, I of 0, but we're trying to access the previous element from 0, which doesn't exist. So the index minus 1 of nums doesn't exist. It's undefined. And so we're going to get an error. How do we fix this? Well, we can say that if in the first case, what are we doing? We're doing the current number 1 plus the previous sum, which doesn't exist. We can imagine that it's 0, so it's 0 plus 1. So this would work. However, I think a slightly cleaner solution is just to say that, well, we know that the first number will not change. It's 1 here, and then it will be 1 here. So we can actually just skip the first number, start at I equals 1, and then we can just submit that. This should pass. Surely enough, it does. And there we go. So this is the solution to running sum of 1D array. The first of the LeetCode 75 study plan problems. Subscribe to see more. We will be doing the rest of them in short order here. Thank you, and see you next time.